How does that problem, is that okay with everyone?
Yeah.
Okay. You're going like this, which is usually a sign that something's happening.
No,
You're okay? All right.
Nothing's happening.
It's tricksy in the same way the problem that we worked the last day in class is tricksy. So the question is, there's an airplane that flies out at 298 miles an hour. It turns around and flies back at 318 miles an hour. And the question asks something about, and then it tells you that the first trip was 2 hours longer than the second trip. How long was the return trip? In other words, how long did they fly?
Does it have something, like you can take the extra time, 2 hours, and see how long that was, how many miles in 2 hours? Can you use that?
Oh yeah, you could. I'm not going to do it. I'm not going to build it this way, but it's built into the equation that we'll solve. I'll show you where it is. Remind me, because that's actually the reason I'm not going to do it that way is because it's just not the way I think. It's not wrong. It's just I will fall apart if I try it that way. Okay, it's not wrong though. It works. Okay, so if I'm doing the 4-step method, the first thing I'm supposed to do is try to understand the problem. What might be a useful thing to do if I'm trying to solve this particular problem?
Draw the problem.
Draw a picture. Draw a picture. Draw a picture is often the way to go, is to draw a picture. So let's draw a picture. Interestingly, when Kellen drew me this picture, it was completely backwards in the way. It's not wrong, again, but he draws his arrows backwards from me, which I think is what's strange. So they went out at 298 miles per hour, and they returned at 318. Terrible English.
Honey, you turn your arrows backwards from the
That's right, you guys are confusing.
Reverse the other way.
Yeah, it's not. I don't know. Okay. Just put your left hand. No, it's just confusing. Sorry. Okay. Now there is something that you do have to be careful when you draw this picture. These arrows, if they represent distances, not rates, should be the same length. This is one thing that matters. Is that they both that this distance is the same length as this distance. That matters. If they're different lengths, it's you don't have enough information. Okay? And then the other part that okay, so what if I had stated the problem and said the distance back took 2 hours longer than the distance out?
Isn't that special?
Yes.
Okay.
In the problem statement, I said this trip took 2 hours longer than this trip. If I had done it the other way, what would your intuition tell you?
I'd say that the pilot would be flying in circles.
Exactly. The pilot did something wacky if it took longer going faster than slower, right? So that matters, because actually the first time I wrote the problem I had it backwards, and then I saw that I got a negative number and I went, what's that about? Okay, alright, so far so good. Here's my picture. The other part for this that's probably useful is what should the answer be?
Hours.
Okay, the answer could be hours.
Or time.
So the answer could be time. So hours or minutes or whatever is the appropriate unit. So in the problem statement, I say how long was the return trip? That's sort of, it could mean how long, how many hours. It could mean distance also, right? Either way, right? If I know the time, I know how long I traveled. If I know the distance, I know how long it took, because I know the rate, okay? So I'm going to look for a time, because it'll be easier. Okay, so I should put the answer is in time units or something. Okay? So let's try a couple of simple, so I'm going to do one more step of understanding the problem, which is just plug in some numbers. Okay? Because the one part that I need to do is the distance out, the time out is 2 hours longer than the time back. I need to keep track of that. So if I give you the outbound trip, outbound is 4 hours, I should be able to figure out the rest of it, right? I can figure out the length of time. So what I'm doing is giving you a possible answer and seeing if it makes sense. Does that make sense? So let's figure it out. I'll draw my picture again. There was this guy going at 298 in this direction, this one going at 318, and I'm saying the outbound was 4 hours, which means how fast is the inbound?
2 hours.
2 hours. So let's see, is 4 hours the answer to this question? How would I discover that? This gives me a distance, right? A rate times a time. Tells me how far I went. How long is this arrow? This is a rate times a distance. It tells me how long this arrow is. If 4 hours is the answer, those arrows should be the same length. Having squinting, is that okay? Okay. So what I'm saying is, so you understand where the 298 and the 318 came?
That was the time like going out and coming in.
That was the rate that airplane was flying and the rate that he turned around. So yes. And what I'm saying is, suppose this pilot flew for 4 hours and turned around and flew this way for 2 hours. Did the pilot get back to his landing thing, runway? Or did he crash somewhere?
He overshot.
Or did he, okay, so let's figure this out. So I'm going to figure out how far the plane flew here, and I'm going to figure out how far the plane flew here, and I'm going to see, are these two things equal? That'll help me know whether 4 hours is the answer. So the distance, this is like making a table. I'm not going to make a table, but go ahead.
So I think you can write this algebraically. I'm not sure if that's the right term, but like solve for x. I think you can write it like that, right?
Yes, you will be able to.
Okay.
We're gonna do it, but first I'm gonna just fill in a couple tables because I think I have just enough time to do this. So I'm gonna figure out, this would be the distance. That's not right. This is the distance on the outbound flight going that way. 4 hours at 298 miles an hour is 1196. I think when you multiply it out, anybody who has a calculator would be handy if you check this for me. And the return, 318 times 2, because right, the airplane took 2 hours shorter coming back than going forward. So that's where the 2 came from. I gave you 4, and I said the return trip is 2 hours shorter.
290. Oh wait, no, wrong thing.
What am I supposed to check on it?
318 times 2.
298 times
And
4.
298 times 4.
298 times 4 is 1196, and 218 times 2 is 536.
536.
At least
Okay.
that's what came out when I did it.
So what happened to the airplane? You can
Um,
stand over there, Colin. There should be more. What?
636.
So the difference between these 11, I think is what you're giving me.
Wait, no, I'm giving you 318 times 2.
Oh, you told me 530.
636.
636. Maybe I missed it.
Sorry.
No problem. Good.
I added them.
Okay, good. Awesome. It's fine. So what happened in this situation? The airplane flew for, 11, almost 1,200 miles. Turned around, flew for 600 miles, and landed in the ocean.
And the other one's 1192.
1192.
No, it would be
I don't-
salty there if I-
No, I don't think so. I think you.
Oh no, that's
Real
right.
salty.
Really?
Yeah.
I hate
8 times 4 is 32.
1192? No, we can't because 4 times 8 is 32.
32.
Okay. Yeah.
I said the same thing.
I was doing 16. Okay.
Solar power.
I am doubting your solar power. Okay.
Yes.
So 4 hours is definitely not the answer. In other words, the flight path out is not equal to the flight path in. Okay? So let's try a different one. Is 4 hours too long or too short? Should I try 5 or should I try 3?
3.
Because what I'm trying to do is make a little, I need this number to be a little smaller and I need this number to be a little bigger. Does that make sense? So what I do is try 3. 298 times 3 equals, and then over here I have 318 times, ooh, how far, how long? Times what?
5. No. Yes. I don't know.
What did I do here? I gave you 4 hours. Where did the 2 come from?
One.
The answer's 1.
I subtracted 2, right? The flight path out is 2 hours longer than the flight path in. Go ahead.
298 times 3 is 894.
894. And should there be a 1 here or a 5 here?
A 1
Should be a 1, right? A 1 plus 5, which is 6. No.
A 1, I'm sorry.
There should be a 1, right? Because the flight path out, which is 3 hours in this example, is 2 hours longer than the flight path in, which is 3 minus 2 is 1. So far, so good? All right.
No.
We crashed in the ocean again. So far, so good? Now, what if I give you this? Which would be if I could write.
Delta just fired the pilot.
Yes, we're all or we missed Mars and we're headed off to Jupiter. It's going to take longer.
And
What if I traveled T hours?
Then
What's the
318 would be T minus 2.
There we go. Now here's something that matters a lot.
I did it backwards.
So you had a all right. So it matters. You can do this the other way around, but this is where your difference in the time is coming from. No. Oh, wait. So I'm just supposed to T minus 2, yes? Let's set up the algebraic equation, all right? What about these two should be true if I have the answer?
They would be equal.
They should be equal. So the algebraic equation is 298t is equal to 318 times t minus 2. There's a minus sign right there. There's your algebraic equation. To solve this, you need to isolate the t. That means you got to get the t's together. T is mixed up here with this multiplication. You have to do some algebra to get there.
Can you resend out what we